Greetings, ladies and gentlemen. Today's lesson is brought to you by Cramerica Industries. That's right, delivering the world's best technology to all of us. We're talking about Cramer's rule, Cramer with a C, and this is yet another technique for solving systems. Wonderful. So at this point, we know how to solve graphically, by substitution, elimination, using matrices, and using calculator for graphing or matrices. We've got a bunch of different skills. We're learning yet another one. And Cramer's rule is related to some of our matrix skills. It's going to be great. So I'm just going to jump into Cramer's rule here. I'll show you what it is, I guess, generically. And then we'll do some examples of a 2 by 2 and a 3 by 3. Cramer's rule, I guess, singular. So let's say I've got this. There's going to be a lot of letters, but that's fine. So AX plus BY equals C. And let's have dx, let's see if I know my alphabet, plus EY equals F. Score. So, Cramer's rule is essentially a lot of determinants is all we're going to do. So let's see. So matrix A in this case, all right, is the same coefficient matrix that we had before. So it would be AB and DE. For this situation, right, the coefficient matrix. So the first thing I'm going to do is figure out what is the determinant of A. So I'd figure out determinant of A. So that'll be AE minus DB, right? And I'll find that, right? So that's the determinant of A. The next thing I'll do, all right, this is a little bit craziness, all right? I'm going to find what I'll call the X numerator, all right, X sub n. That's my own notation. That's not Cramer's, and that's also not found in your textbook. But it is convenient for kind of keeping things organized. So what I'm going to do is I'm going to find another determinant of a 2 by 2, but check this. It's going to be almost the same matrix as this. The B and E are going to be the same, except I'm going to take my constants and replace my X column with them. All right, so this is the X's column, right? Because those were the X's coefficients that I just switched out. So for the X numerator, you replace the X's column with your constants. All right, kind of weird. So that would end up equaling, in this case, CE minus FB. Facebook, right? Bam. And then to find the Y numerator, what's the name of that breed of dog? Weimaranen, something like that? Yep, that's what I just said. So let's see, for the Y numerator, look at the symmetry of this concept. It's almost going to be the same as matrix A. I'm going to find the determinant. Except this time, catch this, I'm replacing the Y's column. Oh, what? With my constants. Oh, what? How wonderful is that? Such beautiful symmetry. I love it. So AF minus DC. All right? And now what I'm going to do with all of that, first of all, if my determinant of matrix A ended up equaling 0, I just want to point out that that would tell me, oh, there's no inverse for matrix A, so there's not a single solution for this, but you might end up being able to gain some insight regarding that there's either infinitely many or no solution. Man, my mind just went blank on that. So that will still have the same insight as our previous problems. Now to find the answer to x, little x will actually equal our X numerator over the determinant of matrix A. And our Y solution, little y, will equal our Y numerator over the determinant of matrix A. So it's just a ratio of, for X, it's whatever this was divided by that. Okay? And that's essentially kind of Cramer's rule right there. Those are like our answers, right? So that's what I want. And it's all determinant based, and then you just divide them. So I kind of find that interesting. Actually, I'm going to offer a side quest. I think I'll throw it up tonight. I want you guys to research Mr. Cramer here and figure out where his rule came from. How did he find this? What's his story? And yeah, just write me like a page paper about Mr. Cramer. I think that'd be interesting. I don't know. Side quest, 5 XP, 5 gold pieces. Shoot me an email about it. Bam. So let's do an example, shall we? Here we go. What if I've got 2x minus 3y? Let's see. I lost my cursor. 2x minus 3y equals 9. And let's have x plus 5y equals negative 2. Let's see. Let me straighten out that equal sign. Negative 2. All right. So the first thing I'm going to do, I'm not going to write down matrix A. I think you guys know what matrix A is. It's the coefficients matrix. So let's figure out what's the determinant of A. So this is going to be my like denominator matrix determinant thing for my little ratios that I'll have later. So that would be 2, negative 3, 1, 5, right? This is the determinant that I'm finding. So let's see. So that'll be 10 minus a negative 3. So that looks like it's positive 13, right? Bam, bam, bam. Right? Am I right? Am I right, guys? Am I right? I think so. So for my x numerator, it's going to be almost the same determinant, except I replaced the x's column with what numbers? 9 and negative 2. See, you guys got this. You got this. I'm telling you this stuff. El más fácil del mundo, no? So let's find that determinant. 9 times 5, 45 minus, let's see, we've got trip negatives going here. Negative 2 times negative 3 is positive 6, but I'm subtracting it. What? So that looks like 39 is the x numerator, right? And let's keep going. Let's just find this y numerator. I apologize saying numerator. I say a lot of words intentionally wrong just for the sake of my own entertainment. It's kind of a weird thing that I do. So don't go thinking that's how you pronounce it. Let's see. So this time I'm going to replace the y's column with 9 and negative 2. And we are determinant experts here. 2 times negative 2 is negative 4 minus 9. Right? Let's see. So that's negative 13. And now that I have all of these numbers, I can find my answers. So x is just going to be 39 over 13, or 3. So there's one of my answers. And y is going to be negative 13 over 13, or negative 1. Bam. So I could write that ordered pair, 3, negative 1. Right? So it's actually not that bad. I mean, finding determinants is, I don't know, easy, I think. At least for some of these 2x2 fellas. It's not that bad. No es más mal. Right? And there's kind of a nice little rhythm to the, replace the x column, find the determinant. Replace the y column, find the determinant. Put them over the determinant of this. You get your answer. That's a song I just made up. I'm super creative. Let's do a 3x3. You know what? I'm actually going to scroll over here and up here because 3x3s can take a little bit of space, as you guys are well aware. Am I right? I'm right. I'm right. I know I'm right. Let's see. I'm going to, yeah, you can head on out if you need to. Here's a nice little 3x3 for us. Let's say I've got x minus 2y plus z equals 7. We'll have 6x plus 2y minus 2z equals 4. 4x plus 6y plus 4z equals 14. So here's our 3x3. Yeah, this is going to be some trabajo, some work, but that's okay. So let's see. Let's start off by finding the determinant of matrix A. Now, I haven't shown you Cramer's rule for a 3x3, but I think the pattern will speak for itself. So let's see. So I'll have 1, negative 2, 1. I'll have 6, 2, negative 2. I'll have 4, 6, and 4. Let's see. So to find the determinant of a 3x3, I'm going to copy the first two columns. Remember? Remember this? Recognize this. This belonged to your father. That's what the Sheriff of Nottingham says to Robin Hood in Robin Hood, Prince of Thieves, Kevin Costner film. It's pretty good. I used to like that when I was a kid, especially all the tree forts they made. 4 times negative 2 is negative 8 times another negative 2 is positive 16. Right, so I'm finding the product of all of my primary diagonals. That's 36. I'm going to add them up. 36 plus 16, 40, nope, 52 plus 8, 60. Nice little even 60. 60. Here we go. 4 times 2 times 1 is 8. 6 times negative 2 times 1 is negative 12. 24 times negative 2 is negative 48. Combine all those. Let's see. That's going to be negative 60 plus 8. All right, negative 60 plus 8. So what's that? Negative 52. Okay. So this is equal to 60 minus that negative 52, right? So that's plus 52. So that's going to be what? 112. Did I do that right? I think so. I believe so. Yeah, I think so. I'm counting it. All right. Whoa, I just scrolled down instantly. So there's matrix A. So this is not 0, so that tells me I have a singular solution, right, for this, right? So now I'm going to actually have 3 numerator equations, all right? X numerator, Y numerator, and Z numerator. Makes sense. So for X numerator, here we go. This is going to be so great. You guys could probably figure this out. It's kind of like pattern-tastic. Most of this is going to be the same, except I'll replace the X's column. What? Who would have thought? The X's column with the right-hand side constants. So this is going to be 7, 4, and 14. Right? This is like super nice right here. Right? And so let's find the determinant of this 3 by 3. I'll replace those first 2 columns. 7, negative 2, 4, 2. Man, you guys are doing some serious color switching today. Whew. All right. And let's multiply these primary diagonals. 7 times 2 is 14. Times 4 is 40 plus 56, I think. Negative 2, let's see, negative 28 times another negative 2 is positive 56. Oh, okay. It's a lot of 56s. 6 times 4 is 24. So let's see, this is 112 plus 24. So that's, what, 136, I believe. Let's see, 14 times 2 times 1 is 28. Let's see, 6 times 7, that's 42, negative 2, negative 84. Whew. Man, one mistake here, guys, and then it messes up the whole thing. 4 times 4, 16 times negative 2, negative 32. Let's see, I'm scared of this one here. Let me combine these negatives first. So that's going to be 86 plus 30. Negative 116, and then plus a 28, so it's going to be negative. We know that. Negative what? 88? 98, let's see. So 116 minus 20, no, that would have been, 116 minus 20 would have been 96. And then minus another 8. So yeah, 88, negative 88. So, okay, this determinant, so much work for these, is going to be 136 minus a negative 88. All right, let's see if I can take some change. So that's plus, I know that much. It's going to be over 200. 88 plus 12 of that 36, I think it's 224. Now, I might not take the time for the sake of the length of this video to do y and z. Well, I'll just set them up maybe. But if I want to find out what x is equal to, watch this. All I'm going to do is take the x numerator and divide by that, and I get 2. Right, so I just found one of my 3 solutions, right? 3 parts of the solution. Right, so it's a tad bit of work for the 3 by 3. There's no doubt about it, but it's doable. Let's see. I'll at least set up the determinant for the y one here. So for the y one, it would have been 164 for the vertical. The third column would be 1 and -2, 4. And what do you think I do with the y's column? 7, 4, 14. Yeah, I just replace it, right? So I would find that determinant. And then for the z's column, z numerator, this would be 1, 6, and 4. Let's see, the middle column would be -2, 2, and 6. And this time, the z's column is 7, 4, and 14. So to find y and z, I would just find the determinants of the 3 by 3s here, and then I would divide those answers by 112, and it would work out nice. But like I said, for the length of this video, I'm going to keep it short so we can jump right into some partner work. So, all right, thanks, Internet friends. Bye-bye. Oh, wait, actually, tell you what, I'll even tell you the answer to this. Do I have the answer to this? Where was I? Where did I find these numbers? Maybe not. I don't know if I have the answer to this anymore. I've got so many things that I pull from. Well, 2 was one of the answers. Oh, here it is. 2, -1, and 3. If you're interested, y equals -1, z equals 3. If you end up calculating that out for practice. All right? All right. Bye for real this time.